all. Myself P. Praveena. I am the Assistant Professor of Mathematics in Institute of Aeronautical Engineering College. Today my topic name is Applications of the Laplace Transform. Okay, Applications of Laplace Transform. This is one of the method for the applications of Laplace Transform. It is very useful for solving differential equations. Solving differential equations by using Laplace Transform method. Once again I'll repeat, this is one of the method for finding applications of ordinary differential equations by using Laplace transformation method. Okay, this is very useful for solving ordinary differential equations directly by applying the Laplace transformation. Okay, in this what is the procedure for that? Steps for solving linear differential equations with constant coefficients. Okay, taking Laplace transform of the given differential equation, using differential theorem, reducing the transformed differential equation to zero order, rearranging the equation like L of y is equal to f of p, where f of p is the function of p. And the fourth step, taking inverse Laplace transform of the function f of p is equal to y is equal to L of y of p. Okay, by using these steps, first we have to reduce the given differential equation as Laplace equation form. Okay, what is the first step? Taking Laplace transform of the given differential equation form. Okay, now once they are given one differential equation form, for that apply both sides Laplace transformation operator. And the second step, using differential equation theorem, reducing the transformed differential equation to zero order. What is the theorem here? Theorem reducing the transformed differential equation to zero means I'll explain clearly in the next slide. And the third step, rearranging the equation like L of y is equal to f of p form, where f of p is the function of p. Taking inverse Laplace transform of the function f of p, that is y is equal to L of y of p. Okay, first step, first for the given differential equation, first apply Laplace transform on both sides. Okay, and next use differential equation theorem. That is, what is differential equation theorem here? What is differential equation theorem? This is the differential equation theorem. After applying the Laplace transform here, what is L of f dash of t? F dash of t, either capital or small, p into f of p minus f of 0. If the given equation is in first order differential equation L of f dash of t, now I'll reduce that as p into f of p minus f of 0. And the second one, Laplace of f double dash of t is equal to, what is the form of that? P square f of p minus p into f of 0 minus f dash of 0. Okay, and next continuously, if the nth order differential equation, for that case f power n of t is equal to p power n into f of p minus sigma r equal to 0 to n minus 1 p power n minus 1 minus r minus f power r of 0. These are the differential equation theorem. If the given question is in f dash of t form, for that we have to reduce that as p into f of p minus f of 0. If the given equation in f double dash of t form means, what is the equation form? That is p square into f of p minus p of f of 0 minus f dash of 0. If nth term means, for that case, p power n into f of p minus sigma r equal to 0 to n minus 1, p power n minus 1 minus r minus f power r of 0. Okay, this is the differential equation theorem. Now I'll discuss one question on this method. First question, solve d square y by dx square plus y is equal to 0. What are the given initial conditions here? Y is equal to 1 and dy by dt is equal to 0 when t is equal to 0. Here what are the initial conditions? Y of 0. Okay, first I'll reduce the given differential equation as d square y by dt square plus y is equal to 0. First I'll write that as y double dash of plus y is equal to 0 form. And what are the initial conditions? Definitely they are given the initial conditions for this type of questions. Here first what they are given in the initial condition, y is equal to 1. Y is equal to 1 means y of 0 is equal to 1. And what about the second equation form? Y dash of 0 is equal to 0. Okay, these are the initial condition directly given in the question here. Y is equal to 1 and dy by dt is equal to 0 for the t when t is equal to 0. From that here I'll write dy by dt is 0 means that as y dash of 0 is equal to 0 and y is equal to 1 means that as y of 0 is equal to 1. Okay, already I discussed in the previous slide. What are the steps for that? Reducing as Laplace transform equation here, taking Laplace transform on both sides. Okay, whatever the given equation form here, y double dash of plus y is equal to 0. I'm applying both sides Laplace transform, that is Laplace of y dash plus y is equal to L of 0. By using differential equation theorem, already I discussed in the previous slide here, what is Laplace of y double dash plus Laplace of y is equal to Laplace of 0. What is Laplace of y double dash? Okay, that is p square into L of y minus p into y of 0 minus y dash of 0. Okay, and directly here there is no formula for the L of y. There is no formula for the L of y is equal to Laplace of 0 value is 0 only. Laplace of 0 as 0. Okay, here what is common here? First I'll substitute the initial conditional values. Here y of 0 and y dash of 0 is given in the question. Okay, that is p square into Laplace of y minus p into what is y of 0 here? 1. What is y of 0? 1. P square into Laplace of y minus p into 1 minus what is y dash of 0? Y dash of 0 value is 0 plus Laplace of y is equal to 0. That is, here what is common in this equation? P square into Laplace of y. Here Laplace of y. I'll take common on both the terms here. That is Laplace of y. Okay, that is Laplace of y into p square plus 1 minus p is equal to 0. Okay, from that I'll take next step, that is Laplace of y into p square plus 1 is equal to p. Already it is there each and every step, but I am writing here clearly. Okay, then okay, after taking L of y is common in that equation, it is Laplace of y into p square plus 1 is equal to p. P square of 1 into p is equal to 0. Again, okay, that means how it will convert? Laplace of y is equal to p by p square plus 1. After using each and every differential equation concepts, here Laplace of y dash and Laplace of y dash formula is here p square of L of y minus p into y of 0 minus y dash of 0 plus Laplace of y is equal to 0. From that we got Laplace of y is equal to p by p square plus 1. Okay, now after that taking inverse Laplace transform on both sides. Okay, taking inverse Laplace transform on both sides. That is y is equal to, that is already it is there, Laplace of y is equal to p by p square plus 1. Laplace of y is equal to p by p square plus 1. That is y is equal to here Laplace inverse of p by p square plus 1. What is the formula of Laplace inverse of p by p square plus 1? Here one formula is there directly for this. Laplace inverse of s by s square plus 1. I'll write here Laplace inverse of s by s square plus 1 is equal to cos t. This is the formula. I'm using this formula for that. That is simply this is as Laplace inverse of p by p square plus 1 is equal to cos t. Okay. Therefore, the general solution, therefore the solution as y is equal to cos t. This is the ordinary differential equation for the first question. Once again, I'll repeat here for every question. First, we have to convert that as an operator form. After that, apply Laplace on both sides. And after that, write down that related formulas for y double dash and y dash. And after that, take Laplace of y is equal to p by p square plus 1. And apply both sides on Laplace inverse. Okay, we got the direct answer for this question. This is very simple question. First, I explained very simple question. Therefore, there's a solution for this question as y is equal to cos t. Next question. Use the Laplace transform operator to solve the initial value problem. Y dash minus 2y is equal to e power 3x. Y dash minus 2y is equal to e power 3x and y of 0 is equal to minus 5. In the previous question, okay, in the previous question directly that as in d square y by dt square form. Okay, but here directly question as y dash minus 2y into e power 3x form. Okay, here what are the initial conditions? Use the Laplace transform operator to solve the initial value problem. Y dash minus 2y is equal to e power 3x. Y of 0 is equal to minus 5. Here they are given only one initial condition, that is y of 0 is equal to minus 5. For this question, apply the operator L on both sides of the differential equation. Then use linearity, that initial condition. Okay, apply the operator L on both sides of the differential equation. Then use linearity of the initial condition. That is, what is the given question form? Here, y dash minus 2y. Y dash minus 2y is equal to e power 3x. This is the question. And what are the initial condition for that? Initial condition is y of 0 is equal to minus 5. Y dash minus 2y is equal to e power 3x. This is the given question form. And the initial condition as y of 0 is equal to minus 5. Okay, now from that I am applying both sides on Laplace transform, Laplace operator. Okay, that is Laplace of y dash minus 2y is equal to Laplace of e power 3x. Okay, I am applying both sides on L operator, that is L operator or Laplace operator on both sides. That is Laplace of y dash minus Laplace of 2y is equal to Laplace of e power 3x. Already I discussed in the previous slide what is the formula of Laplace of y dash. Laplace of y dash means here, okay, that is p of L of y minus y of 0. This is the formula for Laplace of y dash. Minus L of 2 of y means 2 into Laplace of y is equal to Laplace of e power 3x. Okay, that is here p into, that is I am writing here p into Laplace of y minus 2 into Laplace of y minus y of 0 is equal to Laplace of e power 3x form. Okay, from that here what is common for the first two terms? Laplace of y is common, that is Laplace of y into p minus 2. Okay, that is minus, what is the initial value for the y of 0 here? Y of 0 is minus 5, that is minus 5 is equal to Laplace of e power 3x formula, that is 1 by p minus 3. Laplace of e power 3x formula is 1 by p minus 3. That is p minus 2 into Laplace of y plus 5 is equal to 1 by p minus 3. Okay, from that I'll take p minus 2 into, okay, Laplace of y is equal to 1 by p minus 3 minus 5. From that, Laplace of y is equal to, okay, 1 by p minus 3, okay, into minus 5 whole divided by p minus 2. Okay. Okay. It will divisible by p minus 2, that is 1 by p minus 3 minus 5 by p minus 2 form. Next continuation here. Is it clear? Okay, first I'm applying Laplace operator on both sides. After that I'm writing the related formulas, and after that I'm substituting the initial values and Laplace formulas. Okay, next continuation. Next, after that Laplace of y is equal to, here what is the LCM for that? Okay, 1 minus 5 into p minus 3 divided by p minus 2. That is 1 minus 5p, okay, minus plus 15 into here p minus 3. First only p minus 3, after that here p minus 2. That is 1 minus 5p plus 15 by p minus 2 into p minus 3. That is minus 5p plus 16 by p minus 2 into p minus 3. Okay, this is Laplace of y. After taking LCM and all, we got the equation as Laplace of y is equal to minus 5p plus 16 by p minus 2 into p minus 3 form. Okay, now after that applying both sides on Laplace inverse. But here once you see, is there any direct formula for the Laplace transformation? There is no direct formula for that case. Once you see here, first I am applying Laplace transform, that is y is equal to Laplace inverse of minus 5p plus 16 by p minus 2 into p minus 3. P minus 3. Is there any direct formula on Laplace inverse? There is no direct formula. For that case, by using partial fractions, first we have to decompose the equation by using partial fractions. When you are using the partial fractions, if the numerator degree is less than of the denominator degree, for that case use partial fractions. That means, what is the formula for that? Here once you see the numerator part, numerator degree has 1 and denominator degree has 2. That means 1 less than 2. For that case, apply partial fractions for the given form, that is minus 5p plus 16 by p minus 2 into p minus 3. That is equal to a by p minus 2 plus b by p minus 3 form. Okay, from that, okay, first what are the unknown values for that? A and b. Okay, once you see, after using partial fractions, here the denominator will be divided as a by p minus 2 form plus b by p minus 3 form. After using the partial fractions, easily we got a and b values, and after that apply Laplace inverse, directly we got the answer for this one and this one. Okay, for that case apply partial fractions here, that is minus 5p plus 16 is equal to a into p minus 3 plus b into p minus 2. Okay, that is, okay, here I'll find first a or b. Okay, if you are finding first a value means let us assume p is equal to 2. For that case, minus 5 into 2 plus 16 is equal to a into 2 minus 3. Directly if you are substituting p as 2 means that is 0. That is minus 10 plus 16. Minus 10 plus 16 is equal to a of minus 1. That is 6 is equal to a of minus 1. Therefore, what is a value here? A is equal to minus 6. Okay. For that, this is a is equal to minus 1. And similarly, find b value. If you are finding b value means, let us take p is equal to 3. That is minus 5 into 3 plus 16 is equal to b of 3 minus 2. A as 0. A as here 0. That is minus 15 plus 16 is equal to b of 1. That is 1 is equal to b. Therefore, what is a and b values? A is equal to minus 6 and b is equal to 1. Now substitute the two values on the above equation, that is a as minus 6 by p minus 2 plus b as 1 by p minus 3. Once you see, after using partial fractions, after using the partial fractions here, we'll convert minus 5p plus 16 by p minus 2 into p minus 3 as minus 6 by p minus 2 plus 1 by p minus 3 form. Okay, next continuation. Next steps here. After writing that as minus 6 by p minus 2 plus 1 by p minus 3, therefore here y is equal to Laplace inverse of minus 5p plus 16 by p minus 2 into p minus 3 is equal to Laplace inverse of, okay, that is minus 6 by p minus 2 plus 1 by p minus 3 form. That is minus 6, that is Laplace inverse of minus 6 by p minus 2 plus Laplace inverse of 1 by p minus 3. Therefore, directly what is the formula for this? Y is equal to here, okay, I'll take minus 6 outside, Laplace inverse of 1 by p minus 2 plus Laplace inverse of 1 by p minus 3. What is the formula for that? Okay, that is minus 6 into Laplace inverse of 1 by s minus a formula. Laplace inverse of 1 by s minus a means what is the formula for that? That is e power 2x plus 1 by p minus 3. What is the formula for that? That is Laplace, that is e power of 3x. Therefore, what is the solution for the given question? That is y is equal to minus 6 into e power 2x plus e power 3x form. This is the answer for the second question. Okay. Next. Okay, next question. Use the Laplace transform to solve y double dash minus 3y dash minus 4y is equal to minus 16x. Okay, here what are the initial conditions for that? Y of 0 is equal to minus 4 and y of 0 is equal to minus 5. Okay, for that question, first apply, same as previous questions here, first apply Laplace transform on both sides. Okay, apply the Laplace transform of the given differential equation form. Here the given differential equation form is y double dash minus 3y dash minus 4y is equal to minus 16x. Okay, now I'm applying both sides on L operator, that is L of y double dash minus 3y dash minus 4y is equal to L of minus 16x. Okay, therefore L of y double dash minus 3 into L of y dash minus 4 into L of y is equal to Laplace of minus 16x. What is the formula of Laplace of y double dash? That is p square into p square L of y minus p of y of 0 minus y dash of 0 minus 3 into, okay, what is y dash formula here? That is 3 into p of L of y minus y of 0 minus 4 into Laplace of y. And RHS side here L into minus 16 into x. Okay, after writing each and every formula here, y double dash formula, this is y dash. Okay, next here, that is, now I'm substituting the initial conditions. Here, what are the initial conditions for that? Y of 0 is equal to minus 4 and y dash of 0 is equal to minus 5. That is p square L of y minus p into, what is y of 0? Minus 4 minus y dash of 0. That is, the y dash of 0 is minus of minus 5 minus 3 into p L of y minus what again y of 0, that is minus 4 minus 4 into Laplace of y, that is equal to minus of Laplace of 16x. Okay, from that, once you see, after substituting each and every value, that will convert like this: p square L of y plus 4p plus 5 minus 3 into p of L of y plus 4 minus 4 of L of y. And what about the RHS side part? Minus Laplace of minus 16x. That is, I'm taking minus outside and 16 outside. Laplace of x formula. Laplace of t formula. What is the formula for that? That is 1 by p square. Okay. Now the given equation reduced like this: p square L of y plus 4p plus 5 minus 3 into p of L of y plus 4 minus 4 into L of y is equal to minus 16 by p square. Okay, next, after substituting all the values, now once you see here, what is common for that? Here I'm taking p square of L of y, and the similar terms next one is minus 3p into L of y. That means minus 3p into L of y. And the next similar term here, minus 4 into L of y. Next, remaining terms are here 4p and next 5 minus 12. That is 5 minus 12, that is minus 7, is equal to minus 16 by p square. Therefore, here what is common? This Laplace of y is p square minus 3p minus 4 plus 4p minus 7 is equal to minus 16 by p square. Okay, from that here, next step, that is Laplace of y p square minus 3p minus 4 is equal to minus 16 by p square minus 4p plus 7. Okay, that is Laplace of y is equal to p square minus 3p minus 4 is equal to minus 16 by p square minus 4p plus 7. Therefore, from that, Laplace of y is equal to what? That is minus 16 by p square minus 4p plus 7 by p square minus 3p minus 4. This is like this. Therefore, Laplace of y is equal to what? Minus 16 by p square minus 4p plus 7 by p square minus 3p minus 4. Okay, next apply inverse Laplace transform on both sides. But after applying inverse Laplace transform operator on both sides, is there any formula for the LHS side part? There is no direct formula for this. Okay, there is no direct formula for this. After that, okay, again I'm using partial fractions decomposition of this expression for L of y. Okay, that is, what is the form of that? Minus 16 by p square minus 4p plus 7 by p square minus 3p minus 4. Okay, now I am using partial fractions on that. That is minus 16 by p square minus 4p plus 7 by p square minus 3p minus 4. That is equal to here. For our convenience, I am taking that minus 16 by p square minus 4p plus 7 by p square minus 3p minus 4 into, multiplying and dividing with p square here. That is minus 16. First I am taking here LCM on that. That is minus 16 minus 4p cube plus 7p square. Okay, by p square into, what are the factors for p square minus 3p minus 4? That is p plus 1 into p minus 4. P square into p plus 1 into p minus 4. Okay, now I'm using on this. Okay, next I'm writing this is minus by using partial fractions here. By using partial fractions, minus 16 minus 4p cube plus 7p square by p square into p plus 1 into p minus 4. That is equal to, how to divide that? A by p plus b by p square and c by p plus 1 plus d by p minus 4. Okay, I'm using this as a by p form plus b by p square plus c by p plus 1 plus d by p minus 4. Now we have to find unknown values of a, b, c and d. Okay, already discussed in the previous problem here how to solve a, b, c, d values. First I'm taking the LCM on this. That is a into, a into p plus 1 into p minus 4 plus b into p plus 1 into p minus 4 plus c into p square into p minus 4 plus d into p square into p minus 4. Both sides, both sides denominators cancel and the remaining minus 16 minus 4 cube plus 7 into p square. Okay, if we want to solve first a value means, now let us assume p as minus 1 and next, p as 4. If you are taken p as 4, here b as 0, c as 0 and d as 0. Okay, let us assume, let p is equal to 4. That is minus 16 minus 4p cube plus 7p square is equal to a into 4 plus 1. Okay, 4 plus 1 and next 4 minus 4. Okay, sorry ma, if you want to take p is equal to 4, here a as 0, b as 0 and c as 0. Okay, directly I'm writing, no need to substitute all values here. Once again I'll repeat, if you are taking p is equal to 4, if you are taking p is equal to 4 here, directly substitute here p is 4 minus 4 0, that is a is 0, b is 0, c is 0 and d of p square into p plus 1 here. P square into p plus 1. That means now substitute here minus 16 minus 4 into 4 cube plus 7 into 4 square is equal to d into 4 square into 4 plus 1. Okay, if you are substituting p is equal to 4, we got directly d value. Okay, that is minus 16 minus 4 into 4 4 is 16 3 is 64 plus 16 into 7 is equal to d into 16 into 5. Okay, now after solving this, we got d is equal to here minus 2. Okay, na? After, if you are substituting P is equal to 4 from the above equation, A as 0, B as 0, C as 0, we got D value. Okay, now simplify this, we got D is equal to minus 2. Okay, therefore here D is equal to minus 2. Similarly, what you have to want here, if you are substituting P is equal to 1 and P is equal to 0, directly we got A value and B value and C value. That is, A as minus 3, B is equal to 4, C is equal to 1 and D is equal to minus 2. Okay, therefore, after using partial fractions, now the given equation will be, okay, like this. That is minus 3 by P plus 4 by P square plus 1 by P plus 1 minus of, that is minus 3 by P plus 4 by P square plus 1 by P plus 1 minus 2 by P minus 4. Okay, now apply Laplace inverse. Laplace inverse. That is minus of Laplace inverse of, okay, I'm taking 3 also outside, that is 1 by P plus 4 into Laplace inverse of 1 by P square plus Laplace inverse of 1 by P plus 1 minus 2 into Laplace inverse of 1 by P minus 4. Therefore, what is the formula of the Laplace inverse here? 3 into Laplace inverse of 1 by P, that is 1, plus 4 into Laplace inverse of 1 by P square, that is 1 by S power n plus 1 formula, that is x, plus Laplace inverse of 1 by P plus 1, that is e power minus x, minus 2 into Laplace inverse of 1 by P minus 4, that is e power 4x. Okay, therefore 3 plus x plus e power minus x minus 2 into e power of 4x. This is the solution for the third question. This is, okay. If you know the partial fractions only, easily we got the solution for the ordinary differential equations. This is the concept of applications of ordinary differential equations by using Laplace transformation. Okay, ma, it's a very, very important method for in engineering level, applications of the ordinary differential equations by using Laplace transformation method. Okay, this is very, very important method. Next class we will discuss some other these related questions on next class. Okay, if you have any doubts, okay, if you know the concept of the partial fractions, this is the very simplest method. What is the procedure for that? What is the procedure for first give a, okay, what is the procedure for that? Once again, I'll repeat here. First, write down the differential equation form, that is y double dash minus y dash plus 0, y double dash minus y is equal to L of 0 or 1, whatever what they are given in the question. First, apply Laplace transform, Laplace operator on both sides. After that, write down that related all formulas, and next, okay, that will be converted as a linear equation form. From that linear equation, we get Laplace of y is equal to, okay, some equation form, that is Laplace of y is equal to minus 16 minus 4p cube plus 7p square by p square into p plus 1 into p minus 1, whatever what it is. Okay, from that, first use partial fractions form. From that partial fractions, okay, if the, when we are using the partial fractions, if the numerator degree is less than of the denominator degree, for that case only we have to apply the Laplace transformation form, the partial fractions formulas. Okay, in that previous methods, for the first question directly we got the answer for that without using the partial fractions. For the second question and third question, there is no possibility to apply directly Laplace inverse formulas. For that case, we are using partial fractions. By the partial fractions, here the partial fractions also, okay, few more methods are there in the partial fractions. For the first method, here we are discussing the first method. What is the partial fractions first method? Here the numerator degree is less than of the denominator degree. For that case, how to divide the partial fractions from a by p plus b by p minus 1 form. Okay, from that, after dividing that as in a by b plus b by p minus 1 form, easily we got the Laplace inverse formulas. For that case, after dividing the denominator as factors of the two terms, now applying Laplace inverse, for that case easily we got the answer for the equation. That's why here I am using partial fractions. This is the main concept of the applications of the ordinary differential equations. Okay, in intermediate level we know that partial fractions, that method only here we can apply for Laplace transformation also. Thank you for all.
Like, share and subscribe. Hit the bell icon for more updates.